Finding the greatest common factor, also known as the GCF. Example 1. Find the GCF of 20 and 45. What we want is the largest number which divides evenly into both numbers. You might be able to figure this out in your head. It cannot be larger than your smallest one because it has to go into both. And so you might guess on this one that it's a 5. But we want a technique. So what we're going to do is break these numbers to primes. So for 20, we could break down to 4 times 5. And then we keep going. So 4 will give us 2 times 2. And 5 is already prime. For 45, we can do 9 times 5. And 9 will keep going. And 5 is already prime. Right? So we want the biggest thing that is common to both. Common means it has to be in both pieces. So we look at the 2's. We're not allowed to use a 2 because the second one, the factors of 45, there is no 2. Also, we can't use a 3 because the first one, the 20, has no 3 in it. So the thing that we see that is common to both is the 5. That is the biggest thing that is common to both 20 and 45. So our GCF is 5. Next, we'll find the GCF of some variable terms, x to the 4th and x to the 7th. For this first problem, we'll write them out. So if we write out x to the 4th, it's 4 copies of x. And x to the 7th would be 7 copies of x. And then we will pick the part that's the same. So we have x in each one. So we have this many x's in x to the 4th. And that's all we can take out of the other one because remember, they have to be common. So our x to the 4th is going to be our GCF. So for variables, what would you say about the GCF? As long as you have the same variable in each one, you will need to go with the lowest exponent so that it will be common. For our next example, find the GCF of 15x to the 6y cubed and 45xy cubed. So we'll do these with numbers and then each type of variable. For the numbers, one trick I always look at is see if the smallest number will divide evenly into the largest. And the 15 does go evenly into 45. So 15 is going to be our GCF for the number. I'm just going to go ahead and write that on the side, but then we'll verify it. And also from our last example, remember if the variable is in each one, you go with the lowest. So the x is in each one, we'll go with just one x. And the y is in each one. These are the same. So y cubed is actually common. Right, so 15xy cubed is actually our GCF, and we didn't really have to write out anything. Let's just verify it though. So for the numbers, we'll break to primes. 15 is 3 times 5. And the variables, you can write them out. So we have 6 x's and 3 y's. 45. So we have 5 times 9. And our 9 gives us some 3's. And we have 1 x and 3 y's. So then we will pick the common parts. First of all, for the 3, we have a 3 here, and we have it in the other, so it is common. The most we can take is 1 because that's all your first term has. We have a 5. It is in both, so it is common. For our x's, we can only take one x because that's all that's in the second one. And for the y's, we have 3 in both. So the 3 times 5, we just multiply those back together. That gives our 15, 1 x from each one, and 3 y's for a y cubed. So 15 xy cubed is our GCF. Next, we'll find the GCF of 10x cubed, 20x squared y, and 40x to the 4th y squared. First, for the numbers, let's try and see if the smallest one divides evenly into all. So 10 does divide evenly into 20. 10 also divides evenly into 40. So our GCF number part is going to be 10. Then for the variables, let's check. Is x in every term? It is. You have to go with the one with the lowest exponent. So x squared is all that's common. And then for the y's, to be a little careful, the first term has no y. So y is not common. It is not part of the GCF. We can verify that GCF by looking at the breakdown of our primes. So first of all, for 2's, we do have 2 in every one, and it has to be common. So we can only take 1 2. For 5's, we do have 5 in each piece. So we can only take a 5, and this is the 2 that we took. So we can take a 5 from each one. That part is common. And that's all of our numbers from this one. Then we look for the x's. So it has to be common. This one has 3, this one only has 2, and this one has 4. So it has to be from this one to be the common part. So you can take 2 out of each one. And then your y's. You're not able to do a y because there is no y in the first term. And then we just multiply our 2 and 5 back together to give 10. So our 10x squared is the GCF. Factoring polynomials by taking out the GCF. Let's factor this polynomial by taking out the GCF. This is from a problem we looked at earlier. I just turned it into a real problem with the signs. So our first step will be to find the GCF. So from our numbers, we will use a 10. From our variables, we'd have to take the lowest exponent, x squared. And we could not take a y because there is no y in the first term. So we find our GCF. We're going to pull that out of all the terms, and it's going to go on the outside. We're going to make one big set of parentheses. Inside the parentheses, you will have as many terms as your original problem. And we're going to go term by term and see what would have to multiply by the GCF to get back to the original problem. So this parentheses will be the missing part. Right, so first for our first term, we have 10 and we want 10. So we're good. We don't need another number. We have x squared, but we would like x cubed. So we're going to have to multiply by an x to get back there. For our next term, we have 10. We'd like to get a 20, a plus 20. So we're going to need a positive 2. Just divide if you get stuck for the numbers, because 10 times 2 is 20. Right? The x squared, that's what we have outside, and that's all we want. So we don't want any more x's inside. Right? We also want to get a y inside, but we don't have any on the outside, so it will need to be here. Then we're going to multiply by something to get our last term. So we have a 10. We would like to get back a negative 40. So we're going to need to multiply by a negative 4. And then for our x's, we have x squared, so 2 x's, and we want 4. So we're missing 2 more x's. Also, we want to get a y squared, and we don't have any y's, so the y squared will need to be here. Right? This is now a product, so it is factored. To check, we will multiply it back. So for our check, we're just going to distribute. So we will have 10x cubed. Remember the exponents add when you multiply. And 10 times 2 is 20. X squared y. And 10 times -4, -40. And x squared times x squared will give us x to the 4th. And a y squared does match our original, so we're good. Now your answer is this line, your factored form, so it needs to be a product. Let's look at some other examples. So for this one, we're going to factor 3m plus 12. First step is find the GCF. So you look at your numbers and try the smallest one. 3 does go into both, so we can use a 3. We cannot do an m because the second doesn't have an m. So our GCF is a 3, goes on the outside, one set of parentheses. You'll have 2 terms in the parentheses because you have 2 terms in the original problem. And then you'll put the missing parts on the inside. So we have a 3, but we would like 3m. So we're missing an m. We have a 3. We would like to multiply and get a positive 12. So we need to multiply by a positive 4. You should check on these because the check is fast and it's easy. You can even do it in your head. To check, you would just distribute back. So 3 times m gives 3m, and 3 times 4 gives 12. Let's factor this problem. 9x to the 6th plus 27x to the 4th. Step 1, find your GCF. So for our numbers, we will actually test the lowest. The 9 works. It's going to divide into 27, so we'll take a 9. For the variables, we have to go with the lowest. We'll go with x to the 4th. That's our GCF, goes on the outside. One set of parentheses. And to get back there, term by term. So first for the 9, we're good. We have x to the 4th. We want x to the 6th. So we would have to multiply by an x squared. To get to our next term, we have 9. We would like 27. So just divide. You need a factor of 3. And we already have all the x's we need outside. So our check, 9x to the 6th plus 27, x to the 4th. So to factor this polynomial, our first step is find the GCF. We can try the 8, that smallest number, but it's not going to work this time because it doesn't go evenly into 12. It would go to the 16. So we're going to have to go smaller than 8. So how about a 4? A 4 would divide evenly into all of those. So we can take a 4. Then we try our variables. We're not allowed to use an x because the last term has no x. And then for our y's, we do have y in everything. We have to take the lowest exponent. That's our GCF on the outside. One set of parentheses. And now to get back there term by term. So we have a 4, would like to get 12. We need to multiply by 3. We need an x squared. And we're good with the y because we have it outside. Next term, we have a 4. We want a positive 16. So you need to multiply by a 4. You're going to need an x to get an x here. And you have one y, you want y squared. So you need one more y. For the last term, you need to multiply by a -2 to get the -8. And you're good with the y. It's on the outside. And you should check on all. So distribute back to do your check. I want to go back for just a moment, and I'm going to work this problem incorrectly. I'm going to miss something and show you what happens. Let's say that I didn't actually see the 4. Let's say I only saw a 2 for the number on the GCF because 2 is common. 2 goes into all of those. So we'll pick a 2. I'm not going to mess it up too bad. Let's go ahead and keep the y. And so to get back, we have 2. We want 12. We're missing a 6. We're missing the x squared. We have the y on the outside. For the next term, we have 2. We want a 16. Just divide. So we're missing a factor of 8. We want 1x. We don't have any, so we need it. We have 1y. We want y squared, so we need one more y. And for our last term, we have 2. We want a negative 8, so we need a negative 4. And our y is okay. We have it outside. Now, if we check this answer, it's going to work. So if you distribute, you're going to get 12x squared y plus 16xy squared minus 8y, which puts you back at the original. The problem is this is not factored completely. Inside, you left a common factor, and your clue here is that all of these are even. So it's partially factored, but it's not completely factored. You could fix it from here by taking out the 2 now, and it would multiply by your 2 on the outside. Or if that's too messy, you could just start over. But it's not finished. It's not factored completely. So you always want to try to find the GCF. Factoring polynomials by taking out the GCF, Part 2. So factor 3m plus 3. First step is to find the GCF, which is going to be a 3. We'll take it on the outside, make our parentheses, and to get back in there, remember you have to have as many terms as the original problem. So inside we have to have 2 terms. For the first term you have the 3, you're missing the m. For the second term you already have the 3 on the outside. What number could you multiply by to get back to 3? It would be a 1. So you have to put the 1 in here. Let's check it. By distributing 3 times m is 3m, and 3 times 1 is 3. It is standard practice if you have a negative on your first term when factoring to choose a negative GCF. So we will choose a negative GCF this time because our first term is negative. So we're going to choose a negative. For the numbers, we can't use a 9 because it doesn't go into 15. We'll have to go smaller. How about a 3? 3 divides evenly into both. For the A's, we have A in both. Go with the smallest, so we can take an A and we can take an X. That's our GCF. 1 set of parentheses. Inside, you're going to need 2 terms to get back there, and we'll just be a little careful with the signs. So first of all, we have a negative 3. We want a negative 15. Multiply by 5. For your variables, you have 1a outside. You want a squared, so you need another a. And you have the x on the outside. For the next term, you have a negative 3. You want a positive 9. You would have to multiply by a negative 3. The a is good. The x is good. Let's distribute back to check to make sure our signs are right. So we'll distribute the negative 3ax times each term. We get negative 15 a squared x, and then we get a positive 9 ax, and that matches our original, so we are correct. Let's look at this example. We're going to factor, and it does start out with a negative term, so we're going to choose a negative GCF again. For our numbers, 21 does not go into 49, so a 7 is going to be our number part for our GCF. For our variables, we can do an x squared and a y. So that will be our GCF. Make our parentheses and then try to get back there. For our first number, we would need to multiply by a 3 to get negative 21. We have x squared, we want x cubed, so we need an x, and we have the y outside. For your next term, you have a negative 7, you want a negative 49. So you're going to need to multiply by a positive 7. The x squared is good, you have it outside, and you need one more y. For our check, we'll distribute back. So we're going to have negative 21 x cubed y, and here you will have a negative 49 x squared y squared. So it does check. Looking at this problem, it looks different than the others. If we did not have the directions that say factor there, we would distribute. In general, though, if it says factor, don't distribute. So the only kind of factoring we know how to do right now is to take out a GCF. So we look at these to see if there is anything the same. And there actually is something the same. It is this big group. So the 2x plus 1 is the same. We can take it out. That is our GCF. And then to get back there, this was only 2 terms because terms are separated by the signs. So our GCF is on the outside. To get back there for the first term, we have the 2x plus 1. We're missing the 5x. And for the second term, we have the 2x plus 1 on the outside. We're missing the minus 3. For this kind, I would not bother to check. Your check takes too much work. You would have to do a FOIL to multiply your binomials, and you would have to multiply out your original to get them to match. Let's look at one more problem, and it does say factor, so we're not going to multiply out. And this one also has that common binomial, so it has this large piece that matches. So we will take it out. That's our GCF. To get back there, remember we'll have as many terms as the original problem, which had 2. So for the first term, we have the 5x minus 2. We're missing the 4x squared. For the second term, we have the 5x minus 2, but we have to multiply by something. If you don't see anything on the outside, then you would multiply by 1 to get back there. Factoring polynomials by grouping. We try to factor problems with 4 terms using a method called grouping. So we have 4 terms. We're going to split the problem into 2 groups. And then from each group, we will try to find a GCF. So from our first group, we do have a common factor. We have an x squared that's common. So we will take that out. Then to get back there, let's see what's missing. So we have x squared, we want x cubed, we're missing an x. For the next term, we're missing a plus 7. Then we'll leave that piece and go to the other group. In this group, we have a common factor of 3. So we'll take that out. And then to get back there, we're missing an x plus 7. What we hope happened with our factoring is that we ended up with a common binomial for our GCF using the whole problem. And we did. So now we will take out the x plus 7 for our GCF. And then to get back just to the line above, for the first piece, we're missing the x squared. And for the second, we have the x plus 7. We're missing the plus 3. If you want to check, a FOIL multiplying the 2 binomials will get you all the way back to the original. Let's look at another problem. So we're going to factor, and we have 4 terms. That's our clue to try grouping. So we're going to make 2 groups. And from our first group, we can take a 2 and a t squared. And then to get back there, we're missing a 4t. We have the entire piece for the second part, but we have to multiply by something. So we'll multiply by a positive 1. Then we'll look at the second group. We can take out a 3. And to get back there, we're missing a 4t plus 1. Then we'll look at the whole problem. And what we hope happened is that we ended up with a common binomial, which we did. So now this is the GCF for the whole problem. We'll take it out. And to get back just to the line above, we're missing a 2t squared plus 3. Let's look at one last example. We're going to factor. We have 4 terms, so we'll try the grouping. So we'll make our groups. From the first group, we can take out a 3x squared. And to get back there, we're missing x minus 2. For the second group, we don't have anything in common. If you look close, it almost matches our group that we have, our parentheses. The only thing different is the signs. We can make that match by factoring out a -1. So we'll take out a -1, and that will leave us an x minus 2. Double check just this piece. So multiply back. -1 times x, -x, and -1 times -2 gives you back a +2. Then we look, and we do have the common binomial. That was our goal. So we can take it out. X minus 2. And to get back there, we're missing 3x squared minus 1. Your clue on this problem that you might have needed to take out a negative GCF, on the third term, it starts out with negative. Remember when we did GCF, if on the first term of something it's negative, we normally take out a negative GCF? Well, that's your clue here.